4, divide and conquer approach. Part A, insertion sort. 8.1, insertion operation. Yeah. All right. So let us look at our old question, problem number 4, sort an array. Revisit it. Here we revisit this question and we try to solve differently. Yeah. We already solved this problem several times. And we will need to solve it a few more times. Yeah. All right, so here, every time we try to use a different way to view, different view to understand it. And we will find a different solution. Yeah. Here, we will use a different way. Divide and conquer way. All right, the strategy. Start with a simple case. Then grow the data size gradually. Yeah, a natural way. Yeah, all right. Every time we increase the size by one by one, okay, to grow the data size, the data size, array size, one by one, and at the end, we solve the original problem. Okay, that is a general description, because from this description, you do not have the implementation details. You need to fill in that implementation details. Yeah. All right, so let's look at the detail part. Question, how to connect two adjacent cases? What do you mean two adjacent cases? Yeah. It's simple, because every time you increase the data size by 1, you are working on two adjacent cases, right? Yeah. Two adjacent cases, one subproblem has one more size than the other one. Okay, two adjacent cases. So how do you connect? What is the relationship between two adjacent cases? We need to explore that relationship. Yeah. All right. Working on the problem size. One by one, remember we start from the simplest case. After that, every time we add a new element to the current solution, new element to increase the problem size. Okay, yeah. So let's do the work. Yeah. Here, based on our intuition, we do this experiment. Yeah. First, we consider an array with just one element. Single element, that's the simplest case, right? Single element array. When we have a single element array, it is already sorted, right? You do not need to do anything. It is already sorted. Okay, yeah, it's done. Yeah. After it is done, we need to move to the next adjacent case, right? That's two elements. How do we look at two element array? This time, based on our strategy, we try to add a new element A1 into our current sorted array. Yeah, because we treat this array as a sorted array. So we want to add A1 into join the elements in the current sorted array and make the result array also sorted. That is our plan. Okay, so you can imagine by one comparison here, this big arrow, yeah, we can understand as one comparison. You will get it sorted, right? Yeah. After A1 is joined with A0, we have a new sorted array, right? Yeah, new sorted array. Then to increase the data size, we consider another new element, A2, and we also want to insert A2 somewhere in the currently sorted array. How about that view? How about that view? Because A2 can appear in 3 different locations, right? Before A0, between A0 and A1, and after A1, 3 possible different locations. Yeah. But after certain number of comparisons, you can put A2 in the right place, right? Yeah. That, if you do that work, you get A2 inserted into a right place of the current sorted array, and you have a new sorted array. Okay. Similarly, you do this kind of thing again and again until you get to this general step. Insert AK into current sorted array with K elements. How about that? The general case. Okay. This view is different from our old views, right? Yeah. So we did selection sort, we did bubble sort. You can see here, this method is completely different from our old solutions. So that makes it interesting. Okay. Yeah. So we will have a new idea, new solution. All right. Let us summarize what we are doing in these experiments. We add a new element to the currently sorted array and make it sorted. Make the whole data set sorted. So that's what we are doing here. Okay. Yeah. All right. So based on that analysis, experiments, we have observation like this. Okay. Insert an element in a sorted array at the right position. That's the main work we need to do. In order to solve the whole problem, we need to do this operation. Yeah. We can treat this as a special operation, right? Yeah, special operation. And we can give a name for it. Insertion operation. How about that? Okay. So we can call it insertion operation. So let us study the insertion operation. If we can provide the details of this insertion operation, we will get the whole solution easily. Okay. All right. Yeah. So let us look at the detailed work for this insertion operation. Okay. Shift elements for insertion. Now we need to fix the details here. Shift elements. Yeah. Because given an array like this, they have the original locations. All the elements in the sorted array, they have their original locations. And there is no room for new element AK. In order to provide some room for new element AK, some of the elements need to be shifted to the right to provide some vacant location for new element AK. That is our implementation view. Okay. All right. So let's do the detailed work. At the beginning, look at, so this location is the original AK location, right? Yeah. Given array, AK has a given location, right? Yeah, here we lift AK, yeah. So we move AK out. Then this location becomes vacant, right? Yeah. After it is vacant, we can shift, elements to the right. All right, yeah. So we lift AK, we put it in some temporary location. This is a temporary location, okay? Then the dashed box, that dashed line box, it is vacant, so we can shift A sub K minus 1 to this vacant location, one position to its right. All right, yeah, one shift operation. If then we do some comparison, if it is possible, if we compare AK with AK minus 2, if this AK minus 2 is greater than AK, we can shift it another position to the right and so on, okay? Yeah, we do this way. At some point, we can find the right position for AK, right? At some point, yeah, yeah. Sooner or later, you will find the right position for AK. Yeah. Here, suppose this arrow gives us the right position for AK. So we can drop AK to this location. How about that? That's the visual understanding. This diagram gives us visual understanding for the implementation details. Compare and shift if necessary. Yeah, we do this kind of operation. Compare and shift if necessary until we find right vacant position for current element AK and then drop it there. In this way, we get a whole array sorted. How about that? How about this visual understanding? Okay, simple. That is just for one insertion operation. One insertion operation, okay? But it is a general insertion operation. You can apply this operation from beginning to end and get the whole array sorted. How about this idea? This idea and the method is called insertion sort. Insertion sort. Okay, yep, all right, yep. Okay, so we complete this step. Yeah. Number of assignments. Yeah. If we use asymptotic notation, big theta of K. Big theta of K. You can consider upper bound and the lower bound. Yeah. Yeah. Big theta of K, usually we use it to describe the average case. Yeah. Because the best case, one comparison. The worst case, K comparisons, right? Yeah, K comparison. But you can think about the average number of comparisons. Yeah. It's also easy to find. Yeah. So we can use big theta of K to describe the average number of comparisons for this operation. Yeah. All right.